This is Honors Geometry, Notes Section 15.1, Finding Volume of Prisms. We're going to have a good old time today, ladies and gentlemen. First page of our notes, it's 2 pages, 1 page front and back, 1 sheet of paper. First page is just terms. We don't want to rush past this because terminology in geometry is everything. First of all, what's a solid? That's a 3-dimensional closed spatial figure. Think of a box as a solid, a box with a top. A polyhedron, a geometric solid with polygons as faces. So here's an example down here of a polyhedron. Each face, in this case, is a different type of polygon. So for example, this front here is a triangle. This right side's a triangle, the back's a triangle, the left side's a triangle, and the base is a rectangle. A face of a polyhedron, one of the polygons that form the polyhedron. Sometimes these get called sides, but a better term is a face. So this gray area is a face. This polyhedron in this picture has 4 faces. This picture up here has 6 faces. There's a front and a back, a left and a right, a top and a bottom. This one here has, I'm going to say 8 faces. It's got this front and this back, and then it's got a top and then a side and another side and a bottom and then this side over here. I think you get the point. An edge, the intersection of 2 faces of a polyhedron. So for example, if we have let's say this blue face and the gray face, they come together and they form what is called an edge. 2 faces intersect, it's an edge. A vertex, the intersection of 2 or more edges. Well, if we take this front face and this blue face, they form this edge. And then we have another edge that's here, and another edge that's here. They would intersect at this point, which we would call a vertex. Yay! A prism, which is what we're trying to find the area of in this section, is finding the volume of a prism. It's a polyhedron that consists of polygonal regions and its translated image in a parallel plane with quadrilateral faces connecting the corresponding edges. Now that sounds complicated, but I assure you, it is complicated. Let's take this polygon and color it for your viewing pleasure. According to this definition, a polyhedron that consists, a prism is a polyhedron that consists of a polygonal region. So let's say that's this blue region here, and its translated image. So let's say I translate this, let's say, up, like so. In a parallel plane with quadrilateral faces connecting the corresponding edges. So the corresponding edge, I would connect these 2, those are corresponding. I would connect these 2, corresponding. These 2, corresponding. And if I connect this one in the back, we wouldn't be able to see it. They would correspond. And now I have this 3-dimensional figure. That is a prism. We got a right prism, a prism whose lateral faces are perpendicular to the bases. So we're going to be dealing with right prisms a lot. So notice this right down here is a right angle. So because of that right angle, that makes this a right prism. So notice the bases. The bases are always parallel to each other. It doesn't matter how we draw a prism, whether it's a right prism or not. In a prism, the bases are always parallel to each other. So these bases are parallel. And then the edges that connect corresponding vertices, those are perpendicular to the bases. That makes a right prism. Here's another example of a right prism. Specifically, if you can name the shape, let me go back to this one. If you can name the shape of the base, this is a triangle, this is called a triangular prism. Because the base is a triangle. Notice that the base does not have to be the top and the bottom. In this next picture, we could have chosen any of the sides to be bases, because this right side is parallel to the left side, so those could be bases. The top is parallel to the bottom, those could be bases. But we've chosen the front and the back to be the bases, which is fine. Those are the red things that we see here. And then the edge that connects the vertex of the, let's say this is the pre-image here, and the image, that's perpendicular to the bases. Next one, we have a hexagonal prism. It's hexagonal because the base is a hexagon. Yes, we could say more than hexagonal prism. We could say hexagonal right prism. We could have done for the previous one a rectangular right prism. Oblique prism, a prism whose lateral faces are not all perpendicular to the bases. So, for example, in this green drawing, okay, we got this base right here. We got this base right here. And there's no indication there's a right angle here. It doesn't appear to be right, so it's an oblique prism. So this will be a rectangular oblique prism. This one here will be a hexagonal oblique prism. The bases we have here and here, and the front, one of the faces is purple. This next picture down here, we got the base down here. Well, maybe this is trying to say, I don't know, the base is the top and the bottom. Anyhow, the picture, it's going to be obvious to you which bases you would like to choose. The two congruent faces that have been translated into the parallel planes are called the bases of a prism. I've mentioned that before. The faces that are not the bases are called the lateral faces. I did not mention that before. All of these examples are right prisms, which means the base and lateral edges are perpendicular to each other. When working with right prisms, the height of the prism is also a lateral edge. Let's look at some examples and see if we have any idea of what's going on. How do you find the volume of a prism? Well, that, my friends, is right here. This is a formula that you got to know. And the capital B, actually, I should probably make this a little bigger. The capital B is the area of the base, and the little h is the height. So when memorizing the formula for the volume of a prism, you say it's the area of the base times the height. Determine the volume of the following prisms. Here's how we're going to do this. We are going to just assume that the colored shape is the base. So for example, in number 1, you could technically choose the base to be any of the sides, well, any of the faces. Number 2, you don't have a choice. The bases have to be the yellow one and the one that's parallel to it. Same with 3, it has to be the purple one and the one in the back that's parallel to it. But number 1, there are several pairs of faces that have a parallel base or have a parallel face to it. So here's how I'm suggesting that you do this. To find the volume of a prism, we're going to take the base times the height. I'm suggesting that you find the area of that base off to the side. We call that side work. Does anybody know why we call it side work? It's because it's work you do off to the side. The base, in this case, is a rectangle. And to find its area, it's little base times little height. Please note, this height is referring to the base. This height is referring to the prism. They're different bases and heights. So looking at this purple shape, let's say the base is 20 and the height is 6. That's going to give us 120. So the volume of this prism is 120 times the height. Do not assume that height means vertical, because it doesn't. Height, in this case, means the side that is perpendicular to the base, and that is 14 centimeters. 120 times 14 is 1,680. The unis we are using is centimeters. Volume is measured in cubes. Let me make sure that that is clear. If I were to have a cube, mistake, like so, that's 1 by 1 by 1. 1 centimeter by 1 centimeter by 1 centimeter. That means that I am trying to figure out how many of these little fellas would fit inside of this three-dimensional shape. How many of these little cubes? That's why this is cubic centimeters. It's how many cubes that are 1 by 1 by 1 that would fit in this. And we could fit 1,680. This cube I drew here was not to scale. You know what I'm saying? Number 2. We want to find the volume of a prism. That is big base times the height. Big base means the area of the base. This particular problem, our base is a triangle. The formula for that is 1/2 the base times the height. So in order for us to figure this out, we have to know what this dimension is and this dimension. This is 5 because it's parallel to this over here. Those are going to be the same. And we do not know what this is. We do know that this diagonal is 13. So how could we figure out this third side of this yellow triangle? We could use the Pythagorean theorem. Or you could recognize this is a Pythagorean triple, a 5, 12, 13. So we got 1/2 the base times the height. The base and height doesn't matter which one you choose is which. So the area of that triangle, the base, is going to be 30 square centimeters. How do you find the volume of a prism? It's the base times the height. The area of the base is 30. The height is the perpendicular distance from one base to another, and that shows here that it's 15. 30 times 15 is 450, and our unis for this are cubic centimeters. There you go. Number 3, pretty similar to number 2, or is it? Here's the beauty of this chapter, is it really is just us getting more practice over the previous chapter, which is finding areas of shapes. Once we find the area of the base, which could be a triangle, a rectangle, a parallelogram, could be a pentagon, could be a regular figure, could be a rhombus, could be a kite, and we just multiply it by another dimension, and that's going to give us the volume. So it's more practice on the previous chapter. To find the volume of a prism, we got to take the area of the base times the height. Okay. So the base in this case is a triangle, and the formula is 1/2 base times height. We currently know one of the dimensions is 6. We don't know the height of that purple triangle. Notice it's equilateral. Just want to make sure that we understand this purple triangle is the base and this back one's the base. In an equilateral triangle, I hope that we understand at this point, it's also equiangular, which means each angle is 60 degrees. If we draw the altitude of this, it does thrice things. It makes a 90-degree angle, cuts the vertex angle in half. Half of 60 is 30. And it also cuts the other side in half, which makes each of these half of 6, which is 3. We need to find that white height. This little fella here is a special right triangle. It's a 30, 60, 90. Opposite 30 is 3. That's the short leg. The long leg is the short leg times the square root of 3. So it's 3 square roots of 3. That's not going to go away. This 30, 60, 90 business. So the height is 3 square roots of 3. Can't move this for some reason. Oh, I've lost controls. I have to reboot it. Happens to the best of us. Rebooting the process. You boot, then you got to boot again. So this height we said was 3 square roots of 3. Half of 6 is 3. 3 times 3 is 9. So the area of the base is 9 square roots of 3. If you want to be specific, it's square centimeters. Volume of the prism is the area of the base, 9 square roots of 3, times the height. The height is the perpendicular distance between these two bases. That's going to give us 90 square roots of 3, and this is cubic centimeters. It's a volume. Volumes are measured in cubes. Number 4. We got this base, which is this purple hexagon. Let's just make the assumption, because I've labeled this terribly, this is an equilateral hexagon. I really should have had markings that made that clear. You really shouldn't have to assume, but in my error, you're going to have to. That hexagon has been redrawn for us so that we can easily look at it and see what's happening. We got to find the area of the base to figure this out. This base is a regular polygon. So to find the area of this base, we got to take half the perimeter times the apothem. The perimeter, hopefully you can see, is going to be 6. I lost pointer controls again. Son of a motherless goat. Notability has been behaving naughtily recently, just when I need her most. If each of these sides are 6, and there are 6 sides, the perimeter is going to be 36. Perimeter is the length of one side times the number of sides. So it's 6 times 6, it's 36. Multiply that by the apothem. Well, we don't know what the apothem is. But it looks like our picture sure showed it to us, didn't it? This is work you need to figure out on your own. I don't know why I have it here. So if this is 6, we want to find the measure of a central angle. Central angle is 360 divided by the number of sides. This is a hexagon, so it has a heck of a 6 sides. So the central angle is 60 degrees. Remind you that the apothem cuts that in half, 90-degree angle. Gives us a 30, 60, 90. Cuts the side in half. It was 6, so it's 3 and 3. So this, oh, here's why I didn't do the work for that. Because we just did that exact thing. Didn't we just do that exact thing? We did. A special right triangle right here. Same special right triangle. So the apothem is 3 square roots of 3. So the area of the base, this polygon, is half of 36, which is 18. 18 times 3 is 54. So the base is 54 square roots of 3. You want to be real specific, square centimeters. Oh, this thing is just dry. To find the volume of a prism, you take the area of the base times the height. That big B means area of the base instead of a little b just meaning one dimension base. 54 square roots of 3 times the height. The height is 10. That's going to give us 540 square roots of 3 cubic centimeters. That's the volume of that right hexagonal prism. Well, I've done some work for you here for this one. I think I was trying to save us some time. We got all the time in the world, am I right? With all the COVID-19 garbage going on. So we're trying to find the area or the volume of this. Now, hopefully you can see that this shape is going to be the same on the front and the back. So this is our base. That's why I have it here in purple. To find the area of this, we can't just throw a formula up there and find it because there's two different parts to it. That's why I broke this down to the purple parts here. So the base in this case is going to be, let's say this is shape 1 and this is shape 2. It's going to be the area of shape 1 plus the area of shape 2. And shape 1 is a rectangle that's 6 by 4, so that's 24. Shape 2 is a rectangle that is 2 by 2. The reason I know this is 2, this whole thing is 6. This is 4. This is the same as this, so this is 4. So let me write that down. So we got 6, we've used 4, so there's 2 left. So it's 2 times 2, which is 4. Which is 28 square centimeters. So the area of that base, which is an odd shape, is 28 square centimeters. To find the volume of a prism, all we got to do, y'all, was take the area of the base times the height. The base, we said, is 28. The height is the distance between the two bases, and that, it says, is 10. So this is 280 cubic centimeters. Number 6. Now this base is wild and wacky stuff. It's a composite shape. This yellow region is what we're calling the base. There's two parts to this. We have a rectangle and we have this triangle. So to find the area of the base, we got to find the area of that triangle. Hold on, I'm getting ahead of myself. I lost pointer controls again. What is this world coming to? The base consists of the area of a rectangle plus the area of a triangle. The rectangle, which is base times height, is 6 by 2, which is 12. If you were to skip base times height, 6 times 2, and just write 12, that's fine. We're living in weird times, so we can make those exceptions. This triangle is half base times height. Please note, this base and this height is different than this base and this height. We lucked out with this triangle because we could call this the base, this is perpendicular, this is the height, and these are both have 1 dash on it. So the base and the height are both 2 square roots of 2. Half There we go. Half of 2 is 1. 1 times 2 is 2. When you multiply two radicals, square roots. Square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. So that mess is just 2 times 2. So this is going to be 16 because 2 times 2 is 4. 4 plus 12 is 16. Once you find the area of the base, it's easy pickings. To find the volume of a prism, you take the area of the base times the height. The base we just established was 16. The height is the perpendicular distance between the bases. That's 3. That's going to give us 48 cubic centimeters. Thank you very much for coming. Have a wonderful, wonderful day. Knock out.